So hi guys, welcome to the channel Learning Competitive Programming with CodeChef. So if you want to master data structures and algorithms and learn competitive programming, this is the one-stop destination for you. Every week we will be posting several videos on various CodeChef problems as well as the videos on various programming paradigms. So one small request to you, then please do subscribe the channel and turn on the bell notification. So a quick introduction about myself. My name is Chirayu Jain. I'm a CodeChef educator. I am from Jaipur Engineering College and Research Center. I also work as a YouTuber and I'm working in a product-based company. So now let's see the problem that we're going to discuss today. The problem is another card game problem. The difficulty level of the problem is cakewalk and the prerequisites of the problem is basic implementation skills. So now let us see the problem statement. Okay guys. So let's start with the problem statement. I'll quickly summarize you what this problem says. So basically there are two players. One is our old famous chef and the second one is Rick. So they are playing a game. So what are the rules of the game? So the first one is the first statement of the problem defines the word power, right? So what is the power? The power of a positive integer is the sum of the digits of that integer. So basically we have been given an integer and the sum of the digits of that integer is the power of that integer. So for example 13, then its digits will be 1 and 3 and 1 plus 3 will be equal to 4. So 4 is the power of 13, right? So basically chef and Rick receive a randomly generated positive integer. So what do we call that? That is final power. So both chef and Rick will receive a final power and the task is to generate a positive integer such that the power of that positive integer is equal to the final power. So first they will be given a final power and their task is to generate a positive integer such that its power, the power which we defined in the statement 1, is equal to the final power. So this is the task and the main aim is to get minimum number of digits in that integer. So the integer which chef and Rick are generating, the main aim is to minimize the number of digits in that particular integer. So what will be the final call? So the final call will be that if the number of digits in the chef's integer is less than the Rick, then chef will win, otherwise Rick will win. And if the number of integers in both the digits, like the chef generated something 5 digits and the Rick also generated like 5 digits. So if the number of digits of both the integer are equal, then Rick will cheat and he will win. So this is the problem statement that we are given. We'll assume that both players play optimally and we need to find the winner of the game. So what will be the input, right? So the input will be the number of test cases first and then will be given PC and PR. So PC is the final power of chef and PR is the final power of Rick. So what will be the output? So the output will contain two spaced integer. For each test case, what will output? A two spaced integer. So if the chef is winning, then we'll output 0, and if the Rick is winning, then we'll output 1. And what will be the second integer? The second integer will be the number of digits in the integer that is generated by either chef or Rick. If chef will win, then we'll output the number of digits in the chef integer, and if Rick will win, then we'll output the number of digits in the Rick integer, Rick generated number. So what will be the constraints? So this is the important point, guys. What will be the constraints? So the test cases are ranging from 1 to 10 to the power 5 and the value of PC and PR is ranging from 1 to 10 to the power 6. So this is the important factor and we'll see how this factor will affect the solution. And this is the example input, guys. This is the number of test cases and we have been given PC and PR, and for each of the test cases what we are outputting, like for the first test case what we will output 1, that means Rick is winning, and what are the number of digits in the Rick integer? That is 1. Similarly for the second and third case as well. So this is the problem explanation, guys. So the agenda for today is, first what we will do, we'll understand the concept of the problem. Second, we'll look at the naive approach, the first approach that comes to our mind. And the second and third one is we'll look at the optimized approach, so that how we can optimize the naive approach, right? So this is the agenda and the table of contents. Okay, so now let's try to understand the concept of the problem, guys. So if you are not clear with what is the power of a positive integer that is defined in the problem statement, so let's take some examples to clear it out. So first of all, The statement says that the power of a positive integer is the sum of the digits of that integer. So let's see. If we have an example of 17, that what are the digits in 17? That is 1 and 7. So we'll quickly add these two numbers and the power of 17 will become 8. So let's try out some bigger examples, right? So if we have this number like 688952. So what are the digits of these numbers? That is 6, 8, 8, 9, 5 and 2. So we'll quickly add all of these digits and the power it becomes 38. So the power of this big number, that is 688952, is 38. So this is the power of a positive integer. I hope that with these examples the power of positive integer is clear to you. Now coming back to the problem, we have two players. One is our old famous chef and the other one is Rick. So we have been given that we are providing final power to chef and final power to Rick. So we are providing two integers, right? So one is for the chef and one is for the Rick. So we are giving final power to chef and to Rick. So what will be the goal? So the goal of the problem is that both of these will generate a positive integer such that the power of that integer, the power which is defined in the previous example, the power of that integer is equal to the final power. So final power is the number that we are providing to them. So these guys will generate the positive integer. And what will be the winning condition? The winning condition will be the number which has minimum digits in it will win. So for example, if chef generates a number with 3 digits and Rick generates a number with 4 digits, then automatically chef will win. But if both of them will generate a number with equal number of digits, then Rick will cheat and Rick will win the game. So this is the problem statement and the concept through visuals that we are understanding. Now let us take an example. Let us take a random example and let us analyze it. So if we have a final power of 65, so if we are providing final power 65 to any of either Rick or chef, right? So what is the maximum single digit number that I can take out? So I have to generate a number from this final power, and the one thing that will click into my mind is that if I want to minimize the number of digit in that integer which I am generating, so I'll try to get maximum out of this number, right? So maximum single digit number what I can get through this particular final power. So the single digit number will range from 0 to 9. That is clear to us, right? So if we have one digit, the one digit must range from 0 to 9. So what is the maximum one digit I can have? The answer to this is 9. So 9 is the maximum digit that I can take out from this final power. So like if we try to make maximum out of this number, then what I will do? I'll try to make 9 as much as possible. I'll try to make out 9 from that particular number and I'll subtract 9 from it, right? So first the number was 65 and then I reduced 9 from it. So my one digit is 9 and then I again reduce 9 to it. So other digit will also be 9 and then I'll take out 9 from that number, right? So 3 times, 4 times, 5 times, 6 times, 7 times till that particular number, right? That particular number becomes less than 9. So what I'll do, I'll try to take out 9 from that number. Why? Because as we have seen, the maximum one digit number can be 9. So what I'll do, I'll try as much as possible I can take out 9 from that particular given final power. So how many times I took out 9? That is 7 number of time in this particular example, and now I'm stuck with this 2. So I cannot take 9 out of this now because 2 is less than 9. So what I'll do, at last I'll take 2 out from this. So now the number becomes 0 and the overall integer which I am generating is this integer, right? So if we sum all the digits of this integer, that will sum up to 65 and the integer which is generated is this integer, that is 99992. So this is the integer which is generated. So I hope this concept is clear to you. This is the main concept of the problem, right? So let's take one more example to clear out the things better. Suppose final power is equals to 15. So one possible way could be taking a number that is 555. So the power of this number is 5 plus 5 plus 5, that is 15, that is equal to the final power. But one of the most optimized solution could be 96. 555 has 3 digits whereas 96 has only 2 digits. One more possible solution could be 78. But we are not concerned with the value of number. We are only concerned that how many digits are there in the number. So we need to have minimum number of digits. So in 96 also we are getting 2 digits, whereas in 78 also we are getting 2 digits. So now let's try to understand the pseudo code of the concept that we have just discussed now, right? So what I am doing is I am taking an example of final power. So I am taking final power as 82 and the digits that we have till now is 0, right? So what I am doing is I am using a while loop. So while loop is till the final power is greater than 0, and the first if condition is that if final power is greater than 9, then what I am doing is I am subtracting 9 from the final power. Else what I will do, because only a single digit integer will be left, which is the value of which will be less than 9, so I'll make the final power as 0 and increment the digits. So in every iteration I am incrementing digits. So let's see how I am doing that. So initially the final power is 82. So what we'll do, we'll encounter the first condition that is in the while loop, that is if final power is greater than 0. So yes, it is greater than 0, then I'm entering the loop. Now the first if condition states that if final power is greater than equal to 9. So yes, it is greater than equal to 9. Then what I'll do, I'll reduce 9 from the final power. So here it goes. So I'll reduce 9 from the final power, now it becomes 73. And what I'll do, I'll increment in digit. So the digit will be incremented from 0 to 1. Now again I'll enter the final loop, and now I'll see that if final power is greater than equal to 9, yes, again it is greater than equal to 9, right? So I'll subtract 9 from it and increment in digit. So now it becomes 64 and digit is 2. Similarly I'll go again. So now the final power will become 55 and the digit is 3. Again entering the same loop, the final power will now be 46 and the digit will be 4. Again I'll enter the same loop, and now the final power is 37 and the digit is incremented to 5. Again going to the same loop, final power is reduced by 9 and digit is incremented. Again final power is reduced to 10 and digits are 8. Now I'll see that again I'll enter the loop, and now the final power becomes 1 and the digit is 9. So if the final power is less than 9, this condition holds true when the final power is greater than equal to 9. But now the final power is less than 9, so else condition will work, and now my final power will become 0 and digit is incremented. And since the final power is 0, so the loop will not work and will break out from the loop. So the final power finally becomes 0 and the digits are 10. So this is how I am getting the number of digits in this given problem. Now if we move further into the concept, so the question arises that is it necessary that we will use a while loop? Because when you will submit this solution of using the while loop, the test cases are from 1 to 10 to the power 5, and this what we are doing is we are running a loop over a number which ranges from 10 to the power 6, so it will give a time limit exceeded solution, right? So the question will come into our mind that is it necessary to use a while loop? Let's see how we can break a solution and how we can reduce the time complexity of the given solution. So what we are doing is, let us suppose we are taking an example of 73, and what I am trying to do is I am trying to get maximum 9 out of this number as much as possible, right? So how many 9s I can take out from that number is, that is 8 9s, right? 1 2 3 4 5 6 7 8 9s, and the remaining number will be 1. So I'll quickly take out that number 2, and the number of digits in the final integer would be 9. So instead of using a while loop and taking out 9 again and again, what better trick I can use is that I can quickly divide that particular number by 9. So if I divide that number by 9, that the quotient of that division, what it will result to? It will result to the number of 9 that I want to take out, that is 8 9s, right? So 8 number of 9s I want to take out from that particular number, and if the number still remains, that means that the number is not 0. If the number still remains, then what I can do, I can quickly add one more digit to it, right? So total number of digits will be 9, and if it is a complete division, then I need not to have any addition of 1. So this is the main concept of the problem. Okay, so now let's see time complexity of both the solution. So for the naive solution, the time complexity will be order of t into 10 to the power 6 divided by 9, where t is the number of test cases. So what we are doing is, for each test case we are running a while loop, and what that while loop does is that it subtracts 9 until it encounters a number which is less than 9. So how many times we'll encounter 9? That is, in worst case, a number can be 10 to the power 6. So 10 to the power 6 divided by 9, right? So the overall time complexity of the naive solution will become order of t into 10 to the power 6 divided by 9. Whereas for the optimized solution, the time complexity will be order of t. Why? Because we are running a simple if condition in the test cases. So that is of O1 operation. So the optimized solution will run in order of t times. That is why the naive solution won't work, because the overall time complexity becomes much greater than 10 to the power 8, which will give us time limit exceeded. So let's try to implement this concept with the help of this pseudocode. So what I'll do, I'll not use any while loop in the given test cases. So I'll simply use one condition, that is if condition. So if final power modulo line is equal to 0, that means there is a complete division. There is no remainder remaining, right? So if the final power modulo 9 is equal to 0, that means that the number of digits in the integer which is generated by chef or Rick will be final power divided by 9. Otherwise, what will be the number of digits? It will be final power divided by 9 plus 1. Plus 1 because there is a remainder, there is a number which is smaller than 9 remaining in the final power. So that will count up to 1 extra digit. So this is the concept, right? So let us take one example to clear the things finally. So if we have an example of 102, so what I will do, I'll use the if condition. So 102 modulo 9 is not equal to 0, as we can see. So the answer to this will go to else condition, and the answer will be 102 divided by 9 plus 1. That will give us the answer 12. So this is the answer to this particular final power. This is the number of digits in the integer which will be generated by either chef or Rick, and this is the optimal solution for this problem. So let's quickly see how we can implement this whole concept into a code in C++. Okay, so now let's see the coding of this particular question in C++, right? So what I am doing is, first I am using the main include library, that is bits stdc++.h, and then what I'll do in the main function, I'll input the test cases, right? Now what will be the main logic of the problem that we have just discussed? So for each test case, what I am getting is, I am getting two integers, that is PC and PR, the final power for chef and the final power for Rick respectively. Now what I am doing is, I am making two integers. One is the number of digits for chef, I am making an integer digit chef, and the number of digits for Rick, I am maintaining an integer digit Rick. Now as we have discussed in the concept and the pseudocode also, that what we'll do, we'll make a condition, right? So if the final power modulo line is not equals to 0, that means we have the remainder. That means we have a remainder and we need to have an extra digit for it. So what we'll do, we'll divide it, the final power, by 9, and we'll add one extra digit to it, and this will be the final digit for the chef, the optimal final number of digits in the integer generated by chef. Else, if the remainder, if the modulo is equals to 0, then what I'll do, I'll simply divide that particular power by 9. So there is no requirement of an extra digit. So this is how we are calculating the number of digits for chef. Similarly, we'll go for Rick as well. So if the final power for Rick modulo 9 is not equals to 0, that means we require one extra digit. So what we'll do, in the digit Rick, we'll quickly divide power of Rick, final power of Rick, by 9 and add one extra digit to it. Otherwise, what we'll do, we'll simply divide the final power of Rick by 9, and that will be the number of digits in the Rick generated integer. So this is the main logic for the code, and this is the final output that we are going to provide, that if the number of digits for chef is less than the number of digits for Rick, then what will output? Will output 0 and the number of digits for chef. Otherwise, if the number of digits of Rick are greater than or equal to chef, then automatically Rick will win. So we'll output 1 and the number of digits that Rick have in its final generated integer. and that after each test case, what we'll print endl, right? So this is the whole coding for this particular problem in C++. Okay, so now let's try to run this code on CodeChef IDE. So I'll paste the code, language is C++, and try to submit it. Okay, so here's the perfection sign AC. The solution is accepted at CodeChef.